And hello there, AMT 111 members of the Aluminum Kingdom. This is Jay Harbert, your friendly neighborhood A&P instructor, and I'm here to share with you a little information about Rivet Codes. I get asked quite a few questions about this each term, so I wanted to take a little time and let's focus on what each rivet code is, and we'll break it down and make it very, very understandable. Now, generally speaking, the very first part of a code is going to identify what specification the hardware you're focused on is made under. All hardware has to be made to a specification within aviation, and these specifications ensure that no matter who makes that piece of hardware, it'll fit, it'll work, it'll do as it should do. So to start with, for our rivet codes, we're going to start off with MS20. This part of the code simply means that this hardware was made under a military specification. It's a mil-spec part. Other common specifications would be AN, NAS. So this simply identifies what specification it's made under. Now the next part of the code starts to actually talk about the rivet itself. We're going to use this number 470. So as this part of the code, what the 470 represents is simply the head style of the rivet. Now the 470 itself happens to be further defined as a universal. So in this case, it's a universal head rivet, which means it's a protruding rivet, commonly used in lower speed aircraft. We're going to be using quite a few of these in the lab. Another number that you may see show up here occasionally, and we'll be using a few of these, would be a 426. Once again, that represents the head style or the type of head for the rivet, but it also further defines it as a flush rivet. Now, flush rivets are commonly used on aircraft with high-speed airfoils. These are higher performance, higher speed aircraft. So to look back, MS20 tells us it's a mil-spec rivet. 470 indicates what the head style is. Let's look at the next digit or digits in this code. Well, now the rivet that we're going to be using is actually represented by two letters, AD. Now, some of these rivet styles may only include one letter, but an AD rivet tells me the alloy. The letters always represent the alloy. And let me tell you something. If I know the alloy, I also know about the strength of the rivet. It's important to understand what the alloy is because we always install rivets into material that match or come as close as possible to matching the material that we rivet together so that we can eliminate some problems like galvanic corrosion. Well, in this case, an AD is really further defined as a 2117 alloy. And if you remember back from some of your other classes, these first two digits are really critical because what they tell me is that this is a copper-based alloy of aluminum. So if I'm using aluminum alloyed sheet metal, this would be an awesome rivet because it also uses the same alloys as our sheet metal. Really neat how all that lines up, right? Now, the next digit we would want to focus on is going to be a number. Now, this number is preceded by a dash and another number. Let's focus on this one first. This is really, really critical because this number describes the diameter of the rivet. And remember, when we're doing rivet math, we always start with diameter doing our calculations. Now, here's the one good thing about a specification. Every one of these numbers that are representing diameters are always going to be in 1/32 of an inch. That's a constant, and that's part of this code. So if I saw a number 4 rivet, I would automatically know that is a 4/32 rivet. And guess what? A number 5 would be a 5/32, and so on. So your first number always describes your diameter, and our second number, finally, is going to describe our length. Now, the length is a little different. It's actually described in 1/16 inch increments. So in this case, a 4 represents 4/16 in length, a 5/16, and so on and so forth. So at the end of the day, if we were going to use a MS20470 AD 4-4 rivet, what could we answer about that code? Well, it's a military spec, universal head, copper-based alloy, 4/32 or 1/8 inch rivet, and its length is 4/16 or 1/4 of an inch long. Now, if you can put these together and kind of make sense of this, we're in a really, really good place. That'll help you find the correct rivets, order the correct rivets, and understanding these two things right here specifically is going to help us a great deal when we start doing the math to factor our rivet layouts. Remember, it is so critical to remember we focus on diameter first. It's always in 1/32, and our lengths are always in 1/16. Now, how about that? We have deciphered the code. You are now Neo in the aluminum kingdom, and as always, be safe and do good work.